Greetings. My name is Sebastian Zamfir. I am an assistant professor in the Department of Physics and Astronomy at UW Stevens Point. I'm also the director of Beja Observatory and Blocker Planetarium here on campus. It is my great pleasure to talk to you today about stargazing in central northern Wisconsin, with an emphasis on the constellations available for view in the winter and as we transition into the spring. For my presentation, I'm going to use Stellarium, which is a free open source program. You can actually run it directly into your web browser. This program allows you to simulate very accurately the sky for any given location, for a given date and time. I'll go ahead and change the date for March 20th, which is the vernal equinox. And you can do that by clicking on this tab on the lower right corner. The sun is going to set a little bit after 7 p.m. that night of March 20th. And I'm going to simulate the appearance of the night sky a couple of hours after sunset. Vernal equinox marks the official beginning of the astronomical spring. It is the time when the sun transitions from the southern hemisphere of the sky into the northern one. And with a good approximation, we can say that that's the day when the duration of the daylight time and the duration of the night time are approximately equal to 12 hours each. Hence the name equinox, equal nights and days. We will start with the description of the northern part of the sky. See here the letter N indicates direction north, and we'll try to identify a few familiar patterns in that part of the sky. It is interesting to note that the program has an updated collection of artificial satellites, including the International Space Station. So you can use it to identify moving star-like objects in your night sky as well. One familiar pattern that pops up into view is made of 7 bright stars. 1, 2, 3, 4 stars. They trace the bowl of the Big Dipper. And you have 3 bright stars that trace the curved handle of the Big Dipper. The 2 stars on the front side of the Big Dipper are called pointers. Why? If you draw an imaginary line connecting the 2 stars and you extend that line about 1 Dipper's length, they will show you the way to this very, very important star, which is called the North Star or Polaris. The North Star tells you that it's directly due north, and the name Polaris, it indicates that is a bright beacon we have in the proximity of the so-called North Celestial Pole. That means it's very close to where the axis of rotation of the Earth is pointing up in the sky. Another remarkable fact is that the elevation, the altitude of the star Polaris over the northern horizon always matches your local latitude. In central Wisconsin, we are at about 45 degrees northern latitude. That means you'll always find Polaris about halfway between the horizon and the point overhead at 45 degrees. People that live at high latitudes in northern Canada will find Polaris much higher in their sky, closer to the vertical. People that live in Florida or Texas will find Polaris much lower in their sky, closer to their horizon, as their latitude is significantly lower than ours. Polaris belongs to another familiar pattern, which is the Little Dipper. We have 1, 2, 3, 4 stars that mark the bowl, and 3 other stars trace the curved handle. The last star in the handle is Polaris itself. If we have dark skies and good eyes, we can probably trace the full layout of this pattern. Otherwise, it's a bit difficult to observe these fainter members of the collection. One other remarkable pattern is farther to the west. We have a group of 5 stars, 1, 2, 3, 4, 5. If you play connect the dots, where the stars are the dots again, they trace a letter of the alphabet. Usually it is referred to as a W, but it can also be an M depending on how you look at it. This is Cassiopeia the Queen. There are some very neat star hopping techniques that help stargazers to find patterns in the sky. For instance, we can start again with the pointer stars in the Big Dipper. The Big Dipper is here. These are the 2 pointer stars. We can use the imaginary line to find Polaris, but we don't stop here. We keep going along that line about the same distance on the other side, and we arrive at the W pattern of Cassiopeia the Queen. The program allows you to pretend that there is no atmospheric dimming due to the presence of this layer of gas around planet Earth. So if you press on this button, the sky all of a sudden shows up in much better contrast. Another useful feature is that you can visualize the constellations using this kind of connecting lines between brighter stars in the patterns. And now you can see the Big Dipper as part of the larger constellation of Ursa Major, the Great Bear, Ursa Minor right here, and Cassiopeia that we just mentioned. Another neat constellation that I would like to present is Draco the Dragon. You see the head right here and a long tail that's sneaking right between the 2 dippers, between the Little Dipper and the Big Dipper. The reason I want to mention this constellation is because it contains a remarkable star. Right here, this star, which appears rather modest in brightness, it's called Thuban. About 5,000 years ago, when the Egyptians were building the Great Pyramids, this star was of great importance. Polaris is at the present time our North Star. At the time when the Egyptians were building their impressive pyramids, Thuban played that role. The axis of rotation of the Earth is drifting very slowly in the sky, and the effect is noticeable over very long periods of time. 5,000 years, it's a non-trivial amount of time in that regard. So at the time when the Egyptians were trying to orient the pyramids in relation to some important stars and patterns of stars, Thuban was of great relevance for them. One neat way to find Thuban is to connect Mizar, this bright star, at the location where the handle of the Big Dipper is curving, so Mizar is here, with the star Kokab in Ursa Minor, and halfway between the 2 stars along that line you have Thuban. Here is a better view. I zoomed in just a bit So here is Mizar in the Big Dipper, and here is Kochab in Ursa Minor, or the Little Dipper, and halfway between the two you'll find the remarkable star Thuban. Let's now turn our attention to the northeast, and we can do this by dragging the horizon, and we follow the cardinal directions clearly labeled. Here we go, we have the Big Dipper, and right here closer to the horizon we have a bright star, a very bright star called Arcturus. It has just risen. One way to remember its name is to use the curved handle of the Big Dipper and follow this imaginary line that leads you to Arcturus. The English saying is you arc to Arcturus. Arcturus is the brightest star in the constellation the Herdsmen. This is the constellation the Herdsmen. We can use the Big Dipper again to find our way to another important constellation, Leo the Lion. We have the 4 stars in the bowl of the Big Dipper. If we draw a line that is perpendicular to the bottom of the Big Dipper and we move along that line, we'll reach this grouping of stars that trace the shape of a question mark. It is flipped around, that question mark, that's true. Sometimes this pattern is known as the sickle. The dot of the question mark is the star Regulus, and it marks, if you want, the heart of the lion. We have 3 other bright stars right here, 1, 2, 3. They trace apparently a triangle, and that's the hind side of the animal. The star right here marks the tail of the lion, and it's called Denebola. In translation from Arabic, it precisely means the tail, in this case, the tail of the lion. We can use again the artwork to picture the full layout of this important constellation, Leo the Lion. With great anticipation, we move our attention to the southern part of the sky, because this is where we can observe an amazing collection of beautiful patterns, bright stars, which make the delight of the amateur astronomers and stargazers in the winter and spring. With the current settings, where we remove the atmospheric dimming effects, we can actually clearly see the bright concentration of light along the sky, what we call the Milky Way, our home galaxy. It's a bit after 9 p.m. Again, the date is March 20th, the spring equinox, and we are facing south-southeast. We can immediately see the beautiful pattern of Orion the Hunter. We have 4 bright stars. 2 of them mark the shoulders, 2 of them mark the feet. We have 3 stars right in the middle, very neatly aligned. They trace the belt. And we have 3 dots that trace the sword. A large collection of dots trace a bow right here in front of the hunter. And we can use the artwork to clearly see the pattern. The star here in the shoulder is called Betelgeuse. It is an amazing star. It is amazingly large. Current estimates indicate that it is about 800-900 times bigger than our sun. If you drop that star right at the center of our own solar system, it would fill the space all the way through Jupiter's orbit. It is a star that's about to go supernova. It reached the end of its life. It has to die in a spectacular event, a stellar explosion called a supernova. And maybe it has already happened, but the distance to the star is close to 600 light years. That means the light, the information we receive from that star, has to travel for about 600 years to tell us the story of the explosion. 1 light year is the distance that light itself travels in 1 year. Light is the fastest cosmic messenger. It travels at a speed of about 300,000 kilometers in every second, or 186,000 miles every second. 1 light year is about 6 trillion miles. This star Betelgeuse appears reddish in color, and that tells us right away that it is a star of a relatively low temperature. It has a cool surface. I'm not saying cold, it's still hot by our standards, about 5,000 degrees on the Fahrenheit scale, but that puts it on the lower end on the scale of stellar temperatures. In contrast to Betelgeuse, right here on the foot of Orion, we have Rigel, which appears whitish blue, and that indicates that is a star of very high surface temperature. The colors of stars are the first diagnostic we have to measure their temperatures. The belt of Orion will help us in finding our way to this very, very bright star. In fact, the brightest star in your sky, named Sirius. If you draw a line eastward behind the Hunter, you will arrive at Sirius. Sirius is the brightest star in Canis Major, the big dog of the Hunter. There we go, Canis Major. Sirius is the star that marks the throat of the dog. The remarkable brightness of Sirius stems in part from the fact that it's relatively close to us, 8 light years away. The interstellar distances are very, very large. The light that departs from Sirius has to travel for about 8 years before it enters our eyes and we can see it. We can use again the belt of Orion the Hunter to draw a line, but this time westward in front of the Hunter, and it will show us the way to this grouping of stars that apparently form a letter, shows like a V, that is the Hyades cluster. The Hyades cluster also marks the face of Taurus the bull, yet another constellation you are probably familiar with. So this is Taurus, this is its face. There is a bright star here that marks one eye of Taurus. The name of that star is Aldebaran. Many stars have names that start with the particle al, and they are Arabic in origin. So the eye of Taurus does not physically belong to the rest of the stars in the Hyades cluster. It's just a chance projection in that direction, and it shows us being part of that apparent V letter pattern. Now, using again the belt, as we mentioned earlier, we find our way to the Hyades cluster. But if we don't stop here, but we keep going along the line, we'll arrive at another amazingly beautiful grouping of stars, a very compact grouping of stars. This is known as the Pleiades. It really looks like a tiny little mini Dipper. This is a very young cluster of stars. There are hundreds of stars in that cluster. They are all physically bound together. And the group or the cluster is dominated